So during our last lesson, we discussed how to find horizontal asymptote without finding the inverse. This is from last lesson. And we used this technique and there were a lot of practice. So well done everybody for that. And towards the end, we recalled some of these ideas. Vertical asymptote is quite easy. This is when it is undefined. Horizontal asymptote requires that you write it as a mixed fraction. When I say mixed fraction like this, where you have the whole number and a proper fraction, then you apply limit idea to find the equation of the horizontal asymptote. Horizontal asymptote is y equals to something, all right? So what equation of line does it tend to as x tends to infinity? Then we find the x-intercept. Well, of course, we know that from before now. X-intercept is when y is equal to 0. Y-intercept is when x is equal to 0. So now, I said this is not enough to be able to sketch a curve. What we also need, there are two things we also need. One of them is the sign diagram, and the other one is the behavior of the curve towards the asymptote. So we'll be looking at that now. So we'll start from the sign diagram. So that's where we're going to begin today, okay? So come with me to the board. All right. So we're going to pick some, I sent you some pictures of a worksheet, this worksheet especially. Okay, so we're going to pick this and find the sign diagram. So maybe I will do something like this and also maybe something like that. Then I'll give you some of them to practice and send in by WeChat as usual. So after that, then we look at the behavior of graph. Maybe we do the behavior in a comprehensive question like this. So we don't have to do the behavior separately. So we just pick one question and answer this and sketch, all right? And with that, we are done with this idea. If you are fast enough within the first hour, I want us to complete this. So I'll be sending you the paper. If I'm going to give you any graded work, I will. Otherwise, I'll just ask you to practice on your own. And please, I will advise you to please practice, because I'm suspecting that some of you do not practice. And whenever I give you work to do, it is always obvious that you are just speaking, you're just revising that for the first time. I was once a student and I'm still a student. I know what happens when I pick my material to study in the last minute and do a work for my teacher compared to when I prepared ahead. So I have been a teacher and I've been a student, so I understand exactly when I see a work that is less of a standard that is expected. So please, I would advise those of us that always wait till last minute to get the work done, so please desist from it. So I believe this is on the WeChat. Otherwise, I'm happy to send it to our WeChat so that you can follow whatever I'll be doing. So when I give you work, I don't have to display the question while some people are trying to copy from the board. All right, so I'm going to post this on the WeChat, on the group WeChat, of course. That's our group. All right. So when it is time for practice, you can refer to that. Okay, so for now, let's start from the board. Let's write this date and of course, sign diagram. Okay, it is my goal to do the sign diagram and sketching curve. And if we have enough time, I don't want to rush things, but if there is time on our side, we can start composite function. But of course, if there is not enough time, there's no point rushing it, then we can do composite function tomorrow, okay? A lot of things we need to learn on composite function as well. Okay, so let's begin with the date. It's Thursday, it's 12th of March, and it's 2 day to Pi Day, right? Pi Day. A few days time. Pi Day. Everybody know what Pi Day is, right? I'm sure. March 15. That's Pi Day. Anyways. Thursday. March 12. Okay. So sign diagram and sketching. So let's just say sketching. I think we should just, the bigger picture is to sketch. This is rational, please. So our two main objectives for today is to be able to draw the sign diagram for rational functions. Use this sign diagram in sketching the curve. That's just a sketch. Graphs of rational functions. So we go straight into it. You might be wondering, what is sign diagram? A sign diagram is a straight, like a number line, okay, which tells us within certain regions is the curve on the positive y or the negative y. That's what it's about. So if you have a curve that is like this and this, it means from this point, maybe this is some x equals a. From this point, x equals a, all the y values are positive, so this will be positive. And maybe from this point, x equals b, it is negative. What happens in between here? We don't know. So what if it's like this? It means it's also positive. Okay, so how important that is, we will see when we are trying to sketch, because if you do know your equation of asymptote, you probably wouldn't know if the curve is going to be on the positive y or the negative y. What do I mean by that? If my equation of my line asymptote is this, I only claim that y must not touch this line as x tends to infinity. But I don't know if my equation, my curve is like this, which means below that line, or if my curve is like this, which means above that line. In any case, it doesn't touch it. Does everybody understand what I mean by this? Okay, So similarly for the x asymptote, you wouldn't know if you're talking about, is it going to be, so if my x asymptote is like this, are we talking about this, or are we talking about that, or are we talking about this, are we talking about that? So for every asymptote, there are 4 possibilities, as you can see. So which exactly is the one we're talking about? That is the purpose of the sign diagram, okay? That's the purpose of the sign diagram. All right, so we get right to it. To do the sign diagram, these are the major steps. So I would say sign diagram. to make it easier, step 1. So steps 1. Steps to draw diagram for the rational function. Okay, step 1, find, so maybe this rational function is called h. So h is f over g. Okay, rational for the function h, of x, which is, because it's rational, so it's going to be some f divided by some g. Please confirm if you understand what I've written so far. Okay, thank you. So, first is to find out when h of x is equal to 0. Find out when h of x is 0. And find out when h of x does not exist. Okay. The third is to find out if h of x is positive or negative between the values, should I say in the interval outside the values, not just in between these values. The intervals outside the values values, should I say from now? Values that we got from 1 and 2, okay? These are a few things, the things you need to take note of. Ready? All right. Let's take one of the problems. Or maybe we'll start with an example from the book. Oops. Okay. Let's see. Examples. Draw sign diagram. One. We have x minus 1 divided by 2x plus 1. Yeah. So Go to step 1. So for the step 1, find out when it is equal to 0. When is the rational function equals to 0, if I may ask? Any rational function is equal to 0 when what? I'm not talking about this specifically. Any rational function is equal to 0 when what happens? Under what condition? It's a rational function equal to 0. When the numerator is 0, yes, Lillian. Okay, can another person tell us when under what condition is a rational function undefined? When denominator is 0. Thank you very much, both of you. Thank you, Karen. Thank you, Crystal. All right, so that's that. You're all right. So this function is equal to 0, okay, when x minus 1 is equal to 0. So you say when x minus 1 is equal to 0, it implies that x is equal to 1. Okay, so that is when it is equal to 0. Should I say this function equals 0 when, so maybe I write the statement. The function if I had called the function f, just say f equals 0 when, okay, but because I didn't call it any f or g or whatever, so I'm writing the function, all right? This function equals, not equation. What's wrong with me? Maybe I didn't get enough sleep. This function equals 0 when x minus 1 equals 0, which means when x is equal to 1. This function is undefined when 2x plus 1 equals to 0, which means when x equals negative half. So for now, this is what we have. Okay, like that. So we have for now. Apart from this, we may now label. When it is equal to 0, we use a straight line to denote that part. So negative half and 1, this is definitely smaller. So negative half will be here. But that's when it is undefined. So you're going to use broken lines at the top like that and write here minus half. Then you use a normal line here, and that is when x is equal to 1. Of course, this is your x. I hope what I said makes sense. Remember, when it is undefined, it must not attain that value. All right, so because it must not attain it, so we use broken lines. But of course, it may attain this value, so that's just 1. So that's a thick line. This is a broken line. Not a thick line, like a normal line. Please confirm if you get my point, please. All right, thank you. So when we do that, so we are now interested in, we now have 3 regions. Okay? We have 3 regions. What do I mean by 3 regions? The region x less than negative half, this place. The region negative half less than x less than or equal to 1, which is this place. And the region x greater than or equal to 1, which is this place. So we are interested in how does this curve behave in these regions. The rest is just trial and error. Okay, so step 3 says find out if h is positive, which means if the function is positive or negative in the interval outside its values. These are these values. The interval outside the values are these dotted points that I just mentioned. Okay, so what we're going to be doing is to substitute random values. Pick a value that is less than minus half. I pick minus 1. Okay, do we all agree? -1 is in that region. Yes? Okay. Substitute -1 into this. What do we get? Is it positive or negative? Substitute -1, do you get positive or negative? Negative? Positive? Uh-oh, positive? Positive? What's going on, Nakita? Wait. You're like, wait, hold up. Positive, positive, all right. So if you put -1, this is definitely, the numerator is going to be negative, denominator will be negative, so it's going to be positive. You can check another one. Put -5. I get -6, and this is going to be -11, so that's the positive. Okay, so substituting random values, we get this to be positive. So, of course, you don't have to, I think you should just show 1 for the sake of learning. When you're writing your real exam, nobody cares about how you get it. But for the sake of learning, I want you to substitute random values. Okay, so put x equals -1. Okay, maybe I should have called this f. Okay, so I'll say f of x is greater than 0. Or you could just say f of x is positive. All right, so in that case, I'm going to put here positive, which means when we sketch the curve, as it approaches this line, it's going to be above the y-axis, above the x-axis. Does it make sense? We'll get to that in that sketching. We don't want to rush the ideas too much. So in between this, okay, or maybe we do this first, which is not controversial. Any positive value, let's say 4. In fact, we can't put 1 because 1 is the line. Let's start with 2. If you put 2, this is always going to be positive, then this will be positive. So that's going to be another positive, right? So I put x equals maybe 3, and f of x is also positive. So this is positive. In between now, if you pick any value in between, 0 is one of them, right? If you put 0 here, what happens? That's negative, that's positive, that's also negative. You agree? Check another one. Maybe half is also there. If you put half here, this is always going to be positive. Half minus this is negative, so that's negative. So do you agree that this is negative? Okay, so put x equals 0 or x equals half, which is within this range. Use a different color now so we can connect it when you are checking what I did. Just green, right? Okay, let's use that. So put x equals half. X equals half is here. You can also try x equals 0. It's also here. You will realize that the function is going to be negative. Does everybody get this? Then this is negative. So that's your sign diagram. So what we have drawn here, this is a sign diagram. This is what we call sign diagram. Usually I will want it to be below, like somewhere here, okay, not here. Because this looks like I already have my sign diagram before I figure out how to do it. Okay. Understood? So let's pick one of the questions in the worksheet. This is a question in your book. It's actually an example in your book. So let's pick one of the questions in the worksheet. The worksheet is already in the WeChat group. So please check. We're going to be doing, maybe I just go to, no, question H looks like the one that we just did now. So we're not going to go into that, okay, even though it doesn't mean the answer will be the same. So how about I just do question D, okay? Let's do 3D together. Okay, so let's do 3D. So 3D is minus 8x, so 2. So let's say f of x equals minus 8x, 3 minus x. Checking again. Yes. So step 1, when is this function equals to 0? Okay, so f of x is equal to 0 when negative 8x equals 0, which implies when x is equal to 0. We are going to divide, not add. Let's be careful, please. F of x does not exist. That's undefined, right? When 3 minus x is equal to 0, which means when x is equal to 3. So I can do a sketch somewhere. I have 0, I have 3. The undefined part is 3, so that's going to be the dots, and this is going to be normal line. So I need to check any value of x that is less than 0, any value that is greater than 3, and any value between 0 and 3. All right? So I can check when x is less than 0. Okay? When x is less than 0, what happens? So this is actually better, not speaking a specific value. Okay? When x is less than 0, f of x, is it positive or negative? Class, when x is less than 0, is f of x positive or negative? If Mr. Cheng is talking to me, you talk to the mic because I'm just saying what you said. I don't check all this stuff, please. I have to keep going on back and forth. So you can always copy later. So please don't drag us back with copying stuff. All right. So do we all agree it's positive when it is less than 0? Everybody agrees? Yeah, it's positive. Now, for less than 0, that's a negative number. So automatically, numerator is going to be positive. Denominator will be 3 minus a number. So that's also positive. So definitely, this is going to be positive. Okay? So I'm just going to write it. So we know this is going to be positive. This is not my root diagram, just trying to know which regions I need to find. Now, when 0 less than x less than, this is less than or equal to x, then less than 3. Remember, this is not going to be a closed, this is going to be an open interval. This is the closed one. Okay? What happens? Can somebody check? And finally, when x is greater than 3, what happens to f of x? Yes, I'm waiting. Go to the chat now. The first one, between the 0 less than or equal to x less than 3, is the function positive or negative? Karen said negative, negative, negative. Everybody says negative. I haven't gotten any response since the beginning of this class from Leo, from Brandy, from Krista C. Okay, Krista C has been responding. I hope Leo doesn't come back or Brandy doesn't come back and say they don't understand, because this is what happens when you don't talk in the class, contribute. Contributing in the class means you can assess yourself and you can prove to yourself that you understand. Yes, that's why you have to contribute. All right, thank you. So everybody says negative. Let's see. So let's just pick a random number like 1. So 3 minus 1 is 2. So that's a positive number, but still negative at the top. Because it is less than 3, okay, this is definitely going to be positive. All right? Because any number you pick here is less than 3, right? So this is definitely going to be positive. 3 minus any number less than 3 is positive. Then negative 8 times a positive number, because this number is not negative. So this remains negative, this remains positive, so everything is negative like you said. What happens when x is greater than 3? Positive, okay, are you sure? All right, when x is greater than 3, there will be negative here, definitely, and this is always going to be negative anyway, so you get positive. So with this, it is, you can now draw, okay? And do not forget that the first part, 0, is the closed one this time. Okay, that's for the 0. And for the 3, you have the broken line, because that's undefined part. And you can put your signs. This is positive, this is negative, and this is positive. Any questions? All right, so Mr. Chen, that's the example, but I want you to apply the second one, which is this. This is more matured writing, not this one. Okay, this one is just being specific, all right? So this is what I prefer. You write this, then you can do that. So when I give you work to do, Leo, please listen very well. I want to see this. I want to see this. Don't just write x is 0, x is 3, and just pretend like it's okay. If it doesn't look like this, it's not acceptable. Leo, can you hear me, please?
Yes.
All right. So everybody go to the worksheet that I send on WeChat and attempt question 3A, B, C. All right, 3A, B, C. Then send in your feedback through the WeChat. You send it to me personally on WeChat. You have to label your axis, please. Don't forget that. And don't forget to label your axis. That's the x-axis. So let's get busy and send to the WeChat group. Mr. Chen, do you need me to go back?
No, it's fine. I got it.
Okay, so I'll give you some time to do this and I'll come back online. I'll pause the video so we don't record the relevant parts. Okay, so once you correct the close interval thing, Brandy, and look at the, instead of writing positive, you can write plus VE, is allowed, okay?
Okay.
So well done. Leo, I'm checking your work now. Leo, I don't know why you like to write differently for front and right. Please look at the board. My label is below the line. My signs are above the line, and compare that with what you sent to me. I sincerely don't know why you like to write what I did not write. Okay, so apart from that, I think the first one is okay. The second one, that looks okay as well. So please check your label again, Leo. Clarissa, A is okay. B is okay. So A and B, okay, Clarissa. Krista K. Krista K, please, your pencil is a bit faint when you take the picture and send. So I don't know. But I can still manage to see, just be more careful so that I can be able to read whatever you have written. And I thought I mentioned that the diagram should be after the calculation is done. Krista K.
Okay.
I told you this shouldn't have been, my diagram should have been here, and you still came back with that. I sincerely don't know how this works with you guys, seriously. So please take note of that. So A and B looks okay. Sorry for those of you that sent like a long time ago. Okay, Mr. Cheng, I'm checking your A question and it looks okay. And your interval, Mr. Cheng, it should be -2 less than or equal to A. And even for the first one, you could say, yeah, okay, I think it's okay. I think we can use
Wait, so
less
the
than. I think
interval
we can
should
use
be
less
what?
than instead of less than or equal to, because when it is exactly equal, it is actually 0. And 0 is neither positive nor negative. Brandy.
Wait, can you say that again, Mr. Daniel?
Yeah, wait.
Brandy, what I'm saying is, I think it makes sense to actually just use less than or true.
Oh, okay.
You guys see what I'm thinking here? Because when we put the equals to, that is when it is equal to 0, right?
Mm.
So when it is equal to 0, it is neither positive nor negative. So if we are concerned about the sign, 0 should also not be included.
You mean for C?
For any interval now, when you are working, when you are trying to find this positive or negative, less than should be used, or greater than for the last one. You get my point? Because if you include this, which means x is equal to 0 is one of the values that produce negative. But when x is equal to 0, the function is 0. The function is not positive, it's not negative.
Okay.
Does that make sense, class? Everybody, apart from those responding, because I didn't hear from the rest of you. All right, so I'm going to correct this as well. Okay, I think we never use the interval here. So please, if I've corrected what you have done, please apologize for that. If you have written less than or equal to or greater than or equal to, please change it in your solution, but you don't have to send it back to me. Okay. Krista C, I'm checking your work now. First one is okay, second one is okay, and third one is okay. Well done. So please don't forget the less than or equal to that. I just corrected myself now. Ms. V, got your work. Yeah, A is okay. B is okay. I haven't gotten C yet.
Mr. Daniel.
Yes, ma'am. Who's that?
Karen.
Hi, Miss K.
Then, like for the graph, do we still use a dotted line or?
Yeah, definitely.
Oh.
Yeah, definitely. Thank you.
Okay.
You know the meaning of dotted line, right? Remember, it doesn't exist at that point. Okay?
Okay.
All right, Leo, I just saw what you sent, all the three. Well done. So Leo, don't forget about the less than or equal to that I've corrected, okay? Lillian. Correct. Nakita received your work, correction. Yes, perfect. So Nakita, don't forget the less than or equal to also.
Yeah, I changed it already.
Yeah, okay. Sorry, I confused everybody. My bad. Okay, so Callista, yep. Good job. Clary. Work checked, correct. Krista K. Work checked. Mr. Cheng. The last work received, checked. Looks like I've checked for everyone. Good job, everybody. Oh, something else came in. Who's that? Oh, okay, it's Karen. Well, what's going on? Oh, okay, that's C now. Okay, that's it. Good job, everybody. So we have been able to sort out the sign diagram. The next thing is the behavior of the graph. The behavior of the graph is actually seen from the sign diagram. Okay, it's actually seen from the sign diagram. So you look at the asymptote, you look at or what have you, and let's see a full question about sketching a graph. Okay, let's see if we can use the example in the book. Can everybody see my screen? Can you see the book?
Only can see the whiteboard.
Uh-oh, sorry. Okay, just a sec. Let's use the book so it can be faster. Can you see the book now?
Yes.
All right. So this is an example in the book. So we can even play the self-tutor so you can hear the explanation. It says, consider this function. Isn't that the function we did before in the example? Is it the same function? I think so. Please do me a favor and speak to the mic because I have to keep going back and forth. Thank you. When I ask questions, I will appreciate you speaking to the mic. There are so many windows, my video of myself to see what is going on. Other windows, so the last thing I want is, bring the chat all the time, please. So please speak to the mic as much as possible. If the mic isn't working, okay, bye, Leo. See you on Monday. Watch the video later. So the question, let's go straight to it. It's 3 o'clock already. The function f of x equals that. Find the vertical asymptote of the function. We don't have issues with this. Find the axis intercept. That means x-axis and y-axis. So x-intercept and y-intercept, I mean. They rearrange the function to find horizontal asymptote. To rearrange the function means to write it in this form. Okay, understood everyone? To rearrange is to write it in this form. Hello?
Yes.
Yes.
All right. So because when you have it in this form, you apply limits, then you can say, oh, the equation of the horizontal asymptote with y is equal to 4, something like that, okay? Anyways. So the next thing is to draw the sign diagram, which you just did, then discuss the behavior of the function, then sketch the function. Now, If you're able to go through A to E, then F is very easy. Now let's listen. Are we ready? Can everybody see this?
Yeah.
All right.
In this example, we consider a rational function and a linear function
Mr. Daniel, we couldn't hear the thing.
Yeah.
You can't hear the explanation?
No, we can't hear it that well.
Did you hear the explanation from the book?
We heard the first
No, we heard
sentence.
the explanation
but that
from
was
the book,
basically
but
it.
not like, yeah, Ethan, you say.
We really only heard the first sentence and then the rest cut off. And even the first sentence was really, it wasn't too clear.
Okay, so maybe because I minimize the volume. How about now? How about now?
No, I think we're not, I don't think we're hearing it from your computer, but through your speakers, which then feed it into your microphone.
So can you hear now?
No, not really.
Oh, yeah. Unfortunately, I can't send it to you. Do you mind turning on your volume?
No, I'm saying like, it's not about the volume, it's the clarity.
Oh.
Yeah. But no, there is a way you can send it though.
How?
I can show you how to do that later.
Send
Like
what?
but you have to like record your computer basically.
Oh, maybe like record on my phone and send it to you guys?
I can show you a way to do it later because it might take too much time right now.
Send what exactly? Send the book or
No, send basically a screen capture or a screen recording from your computer, and they can send to us.
Well,
Because then the audio will be much clearer.
that would be, yeah, I understand that. So I think I'd better just explain it myself then. So I just thought if you watched it, then maybe it will be, to save us a lot of time, then you can do a self-learning. All right, so don't worry about that. Let's go back to the board. Let's take, sorry about that. Unfortunately, that doesn't work as expected. Okay, so let's take from this book. So from the book again, here is it. I share the book with you. Do you have this? Did I send this to you?
I think you sent a question, but not the whole like full questions.
How about this one? Do you have this already?
I think you only sent question 3.
Question 3. Okay, so I'm going to send this now because this is what we want to practice now. Everybody got that? I haven't sent the worksheet itself because I may maybe add 1 or 2 things to it. I don't know yet. So if I'm not adding anything, then I'll send it to you later. All right? So everybody got this already from the WeChat group?
Yep.
All right. So let's pick, actually, let's pick question. So you can have all the 6 questions actually for your own practice later. Now I'm going to pick the question from the book. Okay, I'll use the same question. And I think the same question was our first example. Is it? What's going on? Where's my board? Okay, so let's see. Is it the same? 2x plus 1? No, it's the other way around. Okay, in the first example, we had, can you see the board? We had x minus 1 over 2x plus 1. The example that I want to treat is 2x plus 1 divided by x plus 1. Okay. Like we can try that, then we can also try this. And after that, then we could do the practice. Okay? Okay, let's go. So behavior and sketching. So we just say sketching. So we're going to follow through the same set of questions that we have from the worksheet. And that is the first one, find the equation of the vertical asymptote. We find the axis intercept. We rearrange the function to be able to find the horizontal. Then we draw the sign diagram. Then we discuss the behavior. Then we sketch. Okay, we're going to follow through in the same manner. All right. I'm not sure if we have enough space here. And I don't want to do half here and half in the other page. Anyway, let's do it. So sketching. Rational. Sketching rational functions. So the question is f of x equals, so I'm not going to write all the questions, I'm just going to write the function, okay? 2x plus 1 divided by x minus 1. We're going to follow through the questions, like I said. Question A, say find the vertical asymptote. Now, vertical asymptote is easy. That is when our denominator is 0, right? So all we need to do is put x minus 1 is equal to 0. Then x is equal to 1 is the vertical asymptote. Okay. And B says find the axis intercepts. Axis intercept means both x-intercept and y-intercept, right? So at x equal to 0, which gives us our y-intercept, f of x equals 1 over minus 1, right? 1 over minus 1, which is equal to negative 1. Okay, so basically 0 minus 1 is the y-intercept. Then at y equals 0, this is from last lesson or maybe previous knowledge. At y equals 0, it means 2x plus 1 over x minus 1 equals 0. And when this fraction is equal to 0, it means when 2x, the numerator is equal to 0. And that means when x is negative half. So the other intercept is 0, negative half. That is the x-intercept. So it says find the axis intercepts. Those are the two axis intercepts. C says rearrange formula. So C says rearrange the formula. So rearrange the function, not formula, in order to find the horizontal asymptote. So our function is 2x plus 1 divided by x minus 1. So remember what we did before. We have our x minus 1. So 2 over 1 is 2. So that is what we have outside the brackets. With x minus 1 inside, then we need to imagine opening the brackets. That's 2x minus 2. So what do we need to do? We need to have a 1. No, we need to have a 3. right? Because only a +3 will make everything go back to +1. So this is going to be +3. Please call me if I've made any mistake. Right, so with this, we can break it down into 2. So I have 2x minus 1 divided by x minus 1 and divided by x minus 1.
Mr. Daniel,
Yes, Miss Krista
I
K.
think the x-intercept is wrong.
Oh,
It should be -1/2 and 0.
right. Thank you, Crystal. So that should be -1/2, 0. Thank you. All right. So this is going to be 2 plus, so that's like saying 2 number, right? 2 number, then a proper fraction, the denominator that, okay? So as x tends to infinity, our f of x tends to 2 plus 0. So that means y equals to is the horizontal asymptote. Okay. Then it says draw the function diagram. Then E is draw the function diagram. So I'm going to draw, because we have our y and x asymptote already. So I'm going to put this here because I want to show some interval stuff at the top here. Okay. So remember, I have my when x is equal to, when the function is 0, right? When x is equal to 0 is what? What do we get? -1, okay? How do we get this function diagram from here? You put from step 1, find out what happens when h of x is 0, then find out when it does not exist. H of x is equal to 0 means when y is equal to 0, my bad. So when y is equal to 0 is when this function is equal to 0, okay? And that means x is equal to half. So basically, you need this. Also, when the function does not exist, which means when the denominator is 0, you also need this. X is equal to 1. Talk to me, please. Understood?
Yeah.
All right, good.
Yes.
So we have -half, then we have 1. So which one is the broken line? That is the one of A. So this is the broken line. And this is the normal line. Okay, so let's see. When x is less than this, is it positive or negative here? I'm waiting.
Positive.
Does everybody agree with him? Does everyone agree with him, please? Hello? What's going on here?
Wait, I'm still looking.
Oh, okay. So what's the first one, what's the second, what's the third? So give me your answers.
Yeah, first one's positive.
First one is positive, all right. Second?
Negative.
Negative. Are you sure?
Yeah, it's negative.
Yeah, negative.
Third one?
Positive.
Thank you. Okay. So the next question is, we want to see what happens let's discuss the behavior of the function near the asymptotes. Okay, let's go to the next slide for that. That's question E. This is about the behavior of the functions near the asymptote. So first, we're going to check. Now, what is our x asymptote? Is what? The vertical asymptote. That's x is equal to 1. Okay, so we're going to check what happens when the curve approaches 1 from both sides. And actually, we can get that from here. Look at this. Can everybody see this? Can you see? Okay, let me show. Okay, I'm here. Can everybody see my cursor?
Yes.
Okay.
Yeah.
Now, this behavior, I want to show you the behavior from here for the vertical asymptote first. Remember, the curve is going to look like the vertical asymptote means something like this, right? So we want to see how the curve behaves around this. How the curve behaves around this. Now, when the curve, who is that? When the curve approaches this from this side, it is positive, right? The curve is positive as it approaches from this side. The curve is negative as it approaches from this side. So if the curve is coming from this side, it is actually from below. If the curve is coming from this side, it is actually from above, something like that. Something like this. I'm not saying this is it, but no. So if this is your XY axis, if this is your Y is equal to 0, okay, the line Y is equal to 0, the curve that is approaching from this side is coming from the top. The curve that is approaching from this side is coming from the bottom. So this is what you write. You say as X approaches 1. Yeah, why am I using 1? 1 is the vertical asymptote. Since X equals 1, so that's why we're using 1. As X approaches 1, 1 plus means from the positive side, from here, okay, from above, okay, as it approaches 1 from above. What this means is as X approaches 1 from above. That's what it means. When we say from above, this is X is equal to 1. Okay, this is X is equal to 1. From above means it's coming from here. From below means it's coming from here. Does that make sense? We are looking at it as if this is 1. There are numbers below 1, like 0, -1, -2. There are numbers above 1, like 2, 3, 4. So as the curve approaches 1 from above, as the curve approaches 1 from below, does that make sense? Remember, the curve does not touch 1, okay? It doesn't touch 1. So it's going to be approaching it from this side and from this side. Some will say from the left side, from the right side. So some will say from above, from below. Please confirm if you understand what I just said.
Yes.
Okay. So we say as it approaches from what happens, because this is positive, okay? Because this is positive, you say f of x tends towards infinity. This is positive, okay? f of x tends towards infinity. Here it will be f of x tends towards negative infinity, all right? So we're going to say, as this happens, f of x tends towards positive infinity, that is from above, okay? Similarly, this should have been here. Then from the other direction, as x approaches 1 from below, not minus 1, please, sorry. From below, low battery. As it approaches that, what happens? The function tends towards negative infinity. What do we mean by negative infinity? As it comes from here, this is negative, okay? Negative infinity means you have a situation like this. So this is the x equals 1 stuff, right? So anyone coming from this side is just going down. It's coming from down, or maybe going down. We don't know. Maybe it's going this way, or maybe it's going this way. But in any case, it is like this. Okay? So negative, that's the meaning of this. So it is never up to 0. Okay? And it's never positive. So it's just going towards negative infinity. Please confirm if you get what I mean by this. We're going to see it in the picture soon. Okay? So the other one is, this is for the vertical asymptote. For the horizontal asymptote, what's our horizontal asymptote? Horizontal asymptote is y is equal to 2. Yes. So for the horizontal asymptote, remember, horizontal asymptote is as a result of x tends to infinity, right? Okay. Now, if x tends to infinity towards the left, what happens? When x tends towards positive infinity, what do we get? This is going to still be positive, then it's going to approach this from the positive, from the upper end of 2. It's confusing to some of you. Let's see. I write this out. 2 plus 3 divided by x minus 1. And when x tends to infinity, of course, I didn't separate it from positive infinity or negative infinity. When x tends towards infinity, my y tends towards 2. Now, x tends towards infinity is 2 directions. Is x tending towards infinity on this direction, on the positive direction of infinity, or x tends towards infinity on the negative direction of infinity? Do you understand my point, everybody? Hello?
Yes.
All right. For the positive infinity, this looks still positive, right? So this becomes 0 from the positive side. This becomes 0 from the positive side. So we say this becomes, y approaches 2 from above. So as x tends towards infinity, that's positive infinity now, y, instead of y, f of x, tends towards 2 from above. And as x tends towards negative infinity, for negative infinity, this is going to tend towards 2 from the negative side, from below 2. F of x tends towards 2 from below. Why do I keep writing minus 1? Now, why do we need all this? We're going to see soon. This is the behavior of our curves. This is what I wanted you to listen to in that explanation, because there's a lot of graphic explanation as well. So with these, we can have a sketch like this. When I'm done with this sketch and you still have questions, please say something. So once you draw your x and y axis, it doesn't have to be perfect. I'm just being semi-Nakita, if you know what I mean. Once you have this is the last part. You want to start from the beginning. You have your vertical asymptote, x is equal to 1. So I'm going to say x is equal to 1 here. Then I draw a straight line, which is going to be dotted lines actually. It's not going to be a straight line, unfortunately. Uh-oh. And I don't have anything that can give me a dotted line from this application. Okay. How about we just do in bits? Yeah, let's use that. Okay, so that's our vertical asymptote. What's our horizontal asymptote? That's y equals 2, yeah? Y equals 2, so that's going to be above. Apologies if it doesn't look right. Okay. So remember this is 1, right? So this is x is equal to 1. This is y is equal to 2. Okay, what else do we have from this stuff? We have the intercept. It's going to cross the the y-axis at 0, -1, and x-axis at negative that. Okay, let's note those points. -half. It's going to be somewhere here. -half somewhere here. Then for the y, is going to be 1. No, -1. -1. So whatever curve we are trying to draw will cut here. Okay. Then let's look at what else do we have? We've made use of this. We've made use of this. Okay. This is in the behavior, so there's no need to do it twice. This also was used in the behavior, so let's come to the behavior. When this curve approaches 1 from above, as x approaches 1 from above, this is x. If it approaches 1 from here, the curve is at the top. Okay. Now remember, this curve does not touch this. So the curve, as x approaches 1 from above, okay, the curve tends towards infinity. So remember, as it approaches 1 from above, the curve tends towards positive infinity. Did you see that? Okay. As x is coming closer to 1, this curve goes towards infinity. That's up. So it means we have something like this. Of course, it doesn't touch it. As a matter of fact, once you draw this, you can do the rotational symmetry about this point. Then you know that the gap, you need this gap, right? You also need the gap here, then the rest will come here. Anyway, let's see. As x tends to 1 from below, that's from below, so which means from here, the curve tends towards negative infinity. So as it's coming here, the curve will go down. Okay, but remember, the curve does not still touch this other line. Please confirm if you understand what I'm saying so far, please. I will re-explain after I sketch it.
Yeah.
All right. It's not clear. Karen said, can't hear you.
No, that's from like
That
long
was from
time
the
ago
textbook.
from the textbook one.
Oh, okay. All right. Crystal not clear. Is crystal not clear means the textbook or my explanation?
Textbook.
What?
Textbook.
Textbook. Okay. So everybody still gets a little bit for now. So I'm going to go through it again. So as x tends towards 1 from below, this is 1. From below means from the negative side, all right? The function goes towards negative infinity. So which means it's going to, remember, it doesn't touch this line, right? So it's going to be coming from here and it's going to go down, okay? But even if you don't want to look at it that way, when x tends towards infinity, which means going this direction, the function tends towards 2 from above. You see, so you see it's coming from above, and is moving towards 2. When x tends towards negative infinity, that is on this side, when x moves towards this side, the curve is moving close to negative, is moving close to 2 from below. That is, the curve is coming from below and is moving towards 2. Does that make sense, everybody? And we already know that the curve passes through this intercept. So it's going to go like this. Remember, it's coming from infinity, it doesn't touch it. It's going to cross this. Yeah, I can never get a perfect one anyway. What I'll do is just, whatever I draw, then that will be my intercept, not this dotted line. Okay, so something like that. So this is your intercept. We put the label for the intercept. Our first intercept is 0, -1. X is 0, y is -1. The other intercept is half 0. Is it minus half 0? Yeah. So this is the sketch. Then we just need to put the label. Let me see where it's easier to put the label. Because I've put the intercept here, I can put the label here. So f of x equals 2x plus 1. The label not too big, please. Just something small on the graph. Divided by x minus 1. This is x equals to 1, the black line. Okay, I go through this again. The vertical asymptote is correct. I think all these are not a problem. This is also not a problem. Let's go through it again from here. Because x minus 1 is the x asymptote is x minus 1. The y asymptote is y is equal to 2. The vertical, sorry, is x is equal to 1. So the first two behavior is from the x asymptote. It's from the vertical asymptote. Now the vertical asymptote is x is equal to 1. How does this graph behave around this line, this black line? Okay, so we will check. Okay, when it is coming from the positive side, what happens? When it is coming from the negative side, what happens? Okay, so our focus will be on x. When x approaches 1, okay, from this side, what happens? And we can get that from, so basically, maybe I will erase this part so I can give you more clue. The first two is from your diagram, okay? So clue, this is from sign diagram. Okay, there's no need to waste your time. From your sign diagram, on the right side of 1 is positive. That is, the curve coming from here is always going to be above the y-axis, above the x-axis. So it's always y greater than 0. When it is coming from here, it's always below this x-axis, which means y less than 0 when it is coming from here. And that's exactly what we have said. As x tends to 1 from above, x tends to 1 coming from above, okay? X tends to 1 coming from above. The curve approaches infinity. That is the meaning of this. So basically, your two responses here are either infinity or negative infinity. Infinity when you have plus, negative infinity when you have minus. Is that clear, everybody? Talk to me, guys. Is that clear?
Yes.
Thank you. Please don't type. I'm not reading. Don't type. I don't have time to start opening different windows. All right, so that's taken. For the other part is you consider your y asymptote. So I'm going to write that clearly. So now consider horizontal asymptote. Now, the horizontal asymptote, this is y is equal to 2. This has nothing to do with x is equal to anything, right? Okay, so remember here we started with as x approaches 1 or minus 1, right? The only thing that we can say about x here is x is going towards infinity and x is also going towards infinity. Okay, so there are two directions. The graph is coming close to x for this vertical asymptote. The graph is coming close to x on this side for this same vertical asymptote. For the y asymptote, the graph is moving towards infinity. Okay, moving towards infinity on the positive side. And for the other one also, the graph is moving towards infinity on the negative side. Does it make sense, everybody? Please confirm.
Yes.
Yeah.
Yes.
You know, because this is probably the most difficult part. Now consider that, okay, that is, this is just for the explanation. You don't need to write that in the book. The only thing I need when you're explaining is this, and the other two. Consider horizontal asymptote y is equal to 2. That is what happens as x approaches infinity on both sides. So that's the next thing you will consider. So you will say as x approaches positive infinity, okay? As x approaches positive infinity, remember, you already have this, okay? F of x, which is equal to, you don't have to write this, okay? Which is equal to, so I'm going to just write that here, y is equal to 3 plus x minus 1, 2, sorry. This is 2, and this is 3, okay? So the idea is this. If this is 2 becoming large, it's going to be 0, right? Okay, bring out the calculator, everybody. Let's do something. Do you all have your calculator? Hello?
Yeah.
Yes.
So type in 2 plus fraction 3, let's say 100 minus 1. Look, something like this. So we're going to be changing that 100 to become a bigger number. Okay, does everybody get that? Can you see this?
Yeah.
All right, so check what this is in decimal. What is that?
It just becomes 2.
What do you see on your screen, young man? It's not 2. It doesn't become 2.
Oh, 2 plus 1 over a really big number minus 1, right?
Say what you see for the experiment, please. I'm trying to get to something. I believe some people still don't get this idea. So please don't tell me what I don't want to hear. Thank you. So everybody, what do you see on your screen? With x is equal to 100, what do you see on your screen, class?
2.030.
All right, so we get 2.03, blah, blah, blah. Okay, let's increase that number. Let's change it to 10,000. This is what you see.
Yeah.
How about we add 3 more zeros to what we have? I see about 6 zeros before my 3. Is that what you see?
Yeah.
So you see, it's approaching 2 from above. Can you see that? As x becomes large, okay, the value is getting closer to 2 from above. From above means, because this is more than 2. Okay, this is 2.03. Then it's coming closer and closer and closer. Talk to me, please. Do you understand that? This
Yes.
answer is getting close to 2 from above because it's going down. Now, let's see the other way around. Instead of 100, let's use negative 100. Okay, because it's now going towards negative infinity. So negative 100. What do you have? This is what you should type in. Can you see that? Hello?
Yes.
If you are typing, you're just wasting your time because I'm not looking at it. Can everybody see this, please?
Yeah.
I'm still waiting for replies. Hello?
Yes.
What do you get from this?
$1.970 29703.
So we have 1.970 blah, blah, blah.
Yeah.
So we had 2 more zeros to that. Tell me what you see.
$1.9997 something.
Okay. So let's add 2 more zeros and make conclusion. It's bigger than that, isn't it?
When you sketch the side that doesn't cross the x and y asymptote, x and y equals to 0, the thing, do you just sketch it like with your eye and to measure?
What do you mean? You mean when
Like,
I do this?
Yeah, this side they cross the equals to 0, so you can sketch it. But how about the other side? Do we just
I'm not really following.
know, like the in the first quadrant of this graph, of that graph?
Let's go back to the first quadrant of that graph here.
Yeah, that side, like, do we just sketch it with our like eye and?
Okay, you mean
How to
for
say?
not touching, it doesn't touch this line and it doesn't touch this line.
Yeah, but like you don't know how curved it should be.
It's a sketch. It doesn't, so you don't know.
Oh,
if,
okay.
You don't know if it is here, right? Or you don't
Yeah,
know.
like, yeah, that's what I mean.
No, it's just a sketch. It's a sketch. You don't have to worry about that. As long as you have gone through all these, okay? As long as you have gone through all these, you'll be now look at this. Is just this first, I think A and C is to get the blue line and the black line. Yeah. This B is to get where it crosses here. It's possible the crossing is on the other side, depending on the equation of the curve. Okay, this will help you to achieve E. Okay, especially E. They're the first 2 parts of E. Then, of course, this is from the experiments we did in the calculator. Okay, and once you have all that, and the rest is easy. Any other question apart from Brandy's question?
No.
No.
All right. So please, like I said, when we come back, there will be a series of tests to check all this. It might be maybe 2, 3, 4 tests to avoid everything being together at once, but it will be standardized tests, IB standard papers, technical questions that I expect you to think outside the box. Everything will depend on your understanding of what we have done in these lessons. So in your own interest, practice. You don't have to wait for me to give you homework. Once I give you practice papers, do yourself practice. Send me questions if you have questions with what I ask you to practice. All right? I wish you the best, and I'll see you tomorrow afternoon by 2 o'clock. Bye, everybody.
Bye.
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 Bye.